Algebra and geometry? Yuck! But Miss Pocket Ronnie can help you.
Okay, we are simplifying radicals. If you look up here at the top, I have 1 through 12. I am going to square each one of these numbers. Okay, so I have 1, 2 squared is 4, 3 squared is 9, 16, 25, 6 squared is 36, 49, 64, 81, 100, 121, 144. Okay, so we're going to be concerned with these numbers in the box. Okay, all of these numbers in the box are called a perfect square. If you took the square root of each one of them, you would get a whole number. Square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, and so on. Square root of 64 is 8, square root of 100 is 10. These are all perfect squares. When you take the square root of them, you get a whole number. We are going to use these numbers to help simplify radicals. Look at 4e7, square root of 200. We need to simplify the radical. We are looking for a factor that's a perfect square. One of these numbers that's a perfect square is a factor of this. So factors of 200 are, there's several different factors, but I am looking for factors where one of them is one of these numbers in this box. Okay, so I can break that to 100 times 2. And 100 is a perfect square. So I'm looking for one of these factors. I want it to be a perfect square. So I'm going to use this set of factors. So when you simplify radicals, I'm going to break it up into these factors. Then I say the square root of 100 times the square root of 2. Because rules of radicals, square root of 100 times square root of 2 is square root of 200. So I can break it up into these two factors. I usually write my perfect square first, because now the square root of 100 is 10, and I can't simplify square root of 2 any more than that. Square root of 2 does not break down any further than that, and so if you put in your calculator square root of 200, or you did 10 times square root of 2, you would get the same number. These two things are equal to each other. It's like reducing a fraction. Simplifying a radical, this is equal, it's just in a simplified manner. Look at 4d7. 5 times square root of 80. Okay, so we want to simplify our square root of 80. We want to break it up into factors to where one of them is a perfect square. Well, I do know that I can break it up into 4 times something. 4 times 20. But if I look at 20, 20 can also be broken up into 4 times 5. And I know that that would have another perfect square in it. It's kind of like when you reduce a fraction, you don't reduce it all the way. You keep reducing it until you can't reduce anymore. Okay? So, let's see. I think I could use 16 times 5. Okay? Let's just say, instead of going with 16 times 5, let's just say I went with 4 times 20. I just want to show you that if you don't simplify it all the way, how you just have to keep simplifying. Okay? So, let's just use 4 times 20. So don't lose your 5. Keep writing your 5 in front. So there's my 5. Now let's break square root of 80 into square root of 4 times square root of 20. And because square root of 4, if I covered my 5, square root of 4 times square root of 20 is square root of 80. Okay, square root of 4 is a perfect square, so it'd be 5 times 2 times square root of 20. Don't forget your 5. This is 5 times square root of 4, which is 5 times 2. So that's 10 square root of 20. But I can keep simplifying. My square root of 20 will break up into 4 times 5, and 4 is a perfect square. So I can say 10 times square root of 4 times square root of 5. Now I have 10, square root of 4 is 2, and that 10 times 2 is 20, square root of 5. If I had used 16 times 5, I would have gotten the same thing. So if I had used 16 times 5, I would have said 5 times the square root of 16 times square root of 5. 5 and the square root of 16 is 4, square root of 5. 5 times 4 is 20, square root of 5. So I'm just showing you that if you don't choose the largest perfect square at first, you might have to simplify again. So try and look for numbers that have the largest perfect square. Basically what you can do is take 80. You know 80 will divide by 4. We'll look for other multiples of 4. So go down your list and say, oh, 16 is a multiple of 4. So will it divide by 16? Yes. It'll divide evenly with 5. Okay, let's go down to 4E8. Don't panic because you have a fraction as its coefficient out in front. Okay, just leave your fraction for now and simplify your radical. Okay, so I know that factors of 72 are 8 times 9. 9 is a perfect square, but I also know the factors of 8 are 4 times 2. And the fact that 4 is a perfect square tells me I can do something higher than just 9. So go through your list of perfect squares. Okay, now I see in my list of perfect squares that 36 is divisible by 72. Okay, so now I'm going to use 36. 36 times 2 is also factors of 72. So I'm going to use 36 times 2, so I'm just leave my 1/3 out in front. Break this up into square root of 36. I usually write my perfect square first. Times 2, because square root of 36 times square root of 2 is square root of 72. Leave my 1/3 in front. Square root of 36 is 6 times square root of 2. Now remember, you can make any number a fraction by putting it over 1. So if I put this over 1, now do you see how my 6 and 3 are going to cancel? This is basically like 6 divided by 3. 6 divided by 3 is 2, and then you still have your square root of 2. And that's what that radical would simplify down to.